So what I'm going to cover today is I'm going to cover the beginning of making of a mold. Got the chat open. So I've come up with this landing gear. It seems to be pretty viable. This is the gear. It's got a smaller cross section than some of the previous gears. I narrowed it down, and it seems to be working really well, but I've only got one mold. So what I wanted to do is come up with another mold so I have two of the same part. So I'll give you a quick overview of what I got going and how I got to this point. So basically, when you start from scratch, I mean nothing, where you don't have anything to go off of, you got to come up with something. So what I did originally, I created a balsa wood form, with this shape to it, and I put C-temp over it and waxed it, and I built a little dam up, and I just laid up a bunch of carbon, and it was square. And then I popped that off, and then once you pop that off, then you got to sand it. You take a perma-grit sanding block, belt sander, files, whatever you got to do, and then you file your shape in it, sand it, and you also lay this on a piece of glass or a flat bench, so you get it all set up to where it's not rocking. You got your sides parallel, everything's where you want it. And then usually I just putty up some low spots. You can see here where there's some divots or whatever. So this is the mock-up for the mold, so that's okay. Once you get it all filled up and it's smooth, then you can actually put some wax on it. So I've got about 3 or 4 coats of wax on this right now, so I won't be doing that today. And another important thing is a draft angle, like right around the back here, and then on the front of the gear here. You got to have a draft angle where the flat is, and also the down legs. And that allows, once the part's made, to come out of the mold. So anyway, that's a real quick explanation of how to come up with the pattern. Now, if you already have a gear, you can whittle it down and make it your own, or you can, make it thinner. And once you get the mock-up and the gear the way you want it, and then it's time to make basically this parting board. Let's just call it a parting board. If you make the mock-up out of carbon, when you're whittling it down and you're working this thing down to the shape you want, the carbon will allow you to actually figure out how much cross-section to keep taking away. It'll give you a representation of what your final gear is going to be like. So I recommend making the mock-up out of carbon so you have an idea of what it's going to be like, pretty close to it. So this parting board is nothing but Formica countertop material, and I cut it in a long strip, and then I cut it into small sections, and these small sections are made to actually make the bend. And when it comes time to gluing these together, I just CA them. I'll take this carbon gear and I'll CA this center piece right here to the gear, just tack it, it's all waxed up. And then I'll take another piece of Formica and I'll lay it on a glass plate, keep it all on the same plane, it's important. And then I'll CA it down the back, and I'll just take each one of these sections and CA it together. Now that'll hold it together, for the mock-up. But what I had to do after I got the form CA'd, if you look around the back, you can see some overlap here where when these boards come together, it's sort of like this, okay? You don't have to have them come together exactly. You can just have the overlap. And what I did is I took a Dremel right here and I cut notches to where the overlap is gone. And then I took some epoxy and I took some carbon fiber and I just laid the toe through that notch onto this form. So basically what I've done is I made a form that's not going to come apart under normal handling. Otherwise the CA and the epoxy or whatever, it wouldn't hold together. So on the back of this form, parting board, you can see where I put the carbon. So that pretty much assures that I've got a one-piece deal here. So now at the point here where I'm ready to actually clay this up, and once I clay it up with the right draft angle, and today hopefully I'll put some surface coat on. So if this is clayed up, we'll get to that point here. It's got to be clayed up, re-waxed, and then PVA'd. And then what I'll do is, out of the way, I'll take these plastic pieces. Now this is probably 3/8. You can use 1/4 8. It doesn't matter. This is just Lexan. And I like using clear because when I'm doing the surface coat, I can see down in there and see if I got any air bubbles around the edge of the mold. And you can get this stuff pretty cheap at a plastic supply place. And then I'll clamp this down on the bench just like this. Once the PVA is on this part with the parting board and the gear, and then I'll apply it and waxed. Okay, so as it's sitting here like this, then I'll just clamp the sides like this. And by clamping the sides, then I'll go ahead and put the surface coat in. And that'll allow me to start the mold. Let me check my phone, it pinged. Okay, I just wanted to make sure it wasn't my buddy telling me that my stream wasn't working. Okay, real quick, I mean, the people that have watched this channel before, you've already seen this stuff before in some form or another. But I'll show you what the finished mold looks like. Get a mold here, I'll show you. So all this stuff here that I just showed you will allow you to get the mold. And this is what the mold looks like right here. So it's not a male and female, it's a top and bottom with the cavity in it, the shape of the gear. So when you box this up on the parting board with the gear there, the first part of the mold you make will be this one here. Okay, so this is the pour. So once you put the plastic sides on it, put the surface coat in, then you actually pour this casting. This is high temp resin. And it takes about a day. Sometimes they usually let it go 2 days, you know, on the casting. So once you get the casting made and everything's cured up good and you flip it over, okay, it sits this way. And now you can actually take this off. Now this doesn't match because it's probably a different size. But anyway, you take this off and now you have a landing gear sitting down in the mold. And you leave the gear in this mold. And what you want to do at that point, you re-wax it, re-PVA it, get it all looking good, and if you have little cracks around it, you put more clay in it. And the next step will be more plastic. You take this plastic and you set it this way. And then what you have to do to pour the top part of the mold is you make these 2 little pieces here, and basically you're, I bet you that was loud. Basically you're going to form this, okay? So to actually form this top part, you have to come up with these right here. And these forms go right here like this. And they've got to go right down here where you have the bend. So you place these between the plastic like this, and that dams up the top of it. And they go on each side like this. And that's just clamped, and you can put some clay behind it, you know, to keep them from moving. Whatever you do, you don't want these to move when you start casting. The other advantages of using the surface coat is it locks everything in without the casting pushing out, or, you know, the extra pressure from the casting. When you fill it, the surface coat will lock all these seams in. So of course, once it's dammed up from the sides, once that's cured, okay, then it comes apart. And that's what creates the two-part mold. I won't get that far today. This is just a live stream. I was hesitant to actually turn the camera on to do this. I thought, well, it's going to take me longer to explain it than actually do it. But I thought I'd do it anyway. So that's where I'm at today. Okay, so the surface coat for this thing here, I've got other stuff I'd like to try, but I'm going to use this up. I've got, let's see, HSC. So if you're familiar with resin surfaces, the HSC means high temp surface coat, and the 302 is formulated for nickel mandrels. It's very polishable. Once you actually get this surface coat on your part and it's cured, it's not only is it high temp, you can go up to like 350 with it. But it's also polishable, so if you need to wet sand it and go to maybe 1,000, 2,000 and then rub it out, you can get a really good polish with this 302. And then of course the hardener, it's got a matching hardener. This is the only one I've ever used with the 302. It's a hardener 302. That makes it simple. 302 casting, 302 hardener. The beauty of the resin services system is you can actually mix and match a lot of these hardeners. This here, it only specs out a 302 hardener. Now, some of the times you'll have a casting resin, let's say HAC casting resin. I can't remember the numbers. I got so many numbers rattling around in my brain. HSC 560, I think it's a casting. So they have 3 different hardeners. It depends on the thickness of the casting. Now obviously when you cast this part, the way I figured this casting, I don't figure it vertically because, you know, you've got what 4 or 5 inches. I just figure the thickness. So if the resin hardener for the casting resin specifies up to 2 inches or whatever, I just sort of base it off the thickness of the mold this way. What you're trying to do is adjust the curing agent to the casting resin. It does 2 things. The pot life, obviously, it's either a fast, medium, or slow, I guess the best way to describe it. And the other thing is the exotherm. I mean, once the castings get so thick, it becomes a problem with it creating its own heat. And what will happen, and even some of the molds I've made, you'll see like it shrinks a little bit or it gets dimples in it where it builds up a little heat. So I'm sort of pushing the envelope on that. But a slower cure agent will actually help you with shrinkage. And then all these high temp resins, the surface coat and the casting resins will allow you, once the mold is demolded off the part, your plug, you're able to clamp it together lightly and then put it in the oven and post-cure it. And there's a post-cure schedule, which allows you to use the mold at a high temp. So there's a lot of information real quick. So I'll quit yakking here a little bit, and I'll go ahead and put some clay underneath this part. So hopefully the latency on this thing is okay. I was streaming before and I readjusted this OBS to where it's not quite as, shouldn't buffer as much. So what I like to do initially, I just put 1 drop of CA right in the middle, and that tacks the gear down to that plate. Now the gear has been waxed, and okay, for some reason I got disconnected. So I used 1/8" spacers, so that's the thickness of this core material. And I mixed up this expanding foam, and I poured it right here on this plate glass with the fiberglass on it. And then I took the other plate glass and put on top of it, and it spread out. And basically it created a core material. And this core material is 1/8" thick. And around the edges you can see where it slipped. It created a lot more pressure than I thought. You know, with expanding foam, it went sideways, but it also wanted to push up. So I was trying to hold it down, and it was swimming around a little bit. So I think going forward, if I do the next test sample, I'll take little clamps. I'll glue these spacers in increments around the perimeter, and then I'll use clamps when I put the plate glass on top. So that way I don't have to stand there and hold it down. So like these spring clamps, you know. And this is 1/8. I need to go down to 1/16 or 3/32. This was basically my first test. And obviously it's probably heavier than it needs to be, because this is an ounce and 1/4, 1.2 ounces or something. So if it's a little heavy, you can go to 3/4, especially on a stunner. And then also, instead of 1/8, you go to 3/32. But see, if you look, see how this glass is stuck to that core material? I mean, that's 100% bond right there. I mean, so when I pull up this fiberglass, it's 100% bond to this foam. Now, the way I explained it in the last video, the male and female mold have fiberglass cloth that's cured on it. They come together with that gap built in from the sheet wax. Sheet wax is removed, so your mold halves come together with a gap. So by forming this core, basically there's no airbags, there's no vacuum pump, there's no breather, there's no bleeder, there's none of that. It's a male and female mold with a gap between them. You close it, you clamp it after the foam is poured in there, and it automatically gives you 100% bond. And you know, it cures. And this stuff cures where I pulled it out of the glass on the video, even though it was cut short. But you know, you could put this in a warming box, maybe 100 degrees. I think it helps it out, the properties. And basically you're making a part in less than a day. So the properties are really good. I mean, you know, the rigidity and everything, it's what I'm looking for. And that's 2 pounds per cubic foot. Let's see. Okay, what clay? Yeah, they ended up breaking their mold completely cracked. Okay, yes. I can see that happening. So the molds that I'm making are super rigid. They're I use tooling dough, and let me show you something real quick here. I'll get it. So these molds are really, I could drive a car over this mold, okay? It's glass, and I could probably use carbon. And here's the surface coat. Now this surface coat is what I'm going to put on top of this gear mold. So by the time you get the glass cloth, and then you get the tooling dough, and then more glass cloth, you've got a really rigid sandwich core. Now the thing is, to keep the mold from blowing up, now with the plate glass, I could feel it push up a little bit, but it was all going sideways, but I could feel a little pressure pushing up. What has to happen when you have a male and female mold, when the male mold goes down into female, you have a gap from your sheet wax, but the male mold comes up, and you got to have little feet and little indexing. I'm not sure of the exact configuration, but when it comes together tight, there's a gap all the way around the perimeter, except for a couple points, you know, that actually key the two parts together. And what happens then, the foam comes up, and then it flows out of the mold. Okay, it has to have a place to leave. The guys that do these boats and the hulls and the decks and stuff, if they don't have holes for this stuff to escape, it'll just, you know, it'll bow the whole boat out. So the key is the right amount of foam. You can't really overfill it, but you got to have enough to where it expands and it comes out. Ideally, you'd want it to come out maybe an inch or so or whatever, but if you put too much, what might be happening, you might have a cure out here and it might create pressure here. So that's all got to be figured out, and I think it's pretty critical. So hopefully I'll get away with doing this. That's why I'm going with a lot of small stuff. And that's why I started with the plate glass, because I didn't want to actually go to this until I figured the plate glass out. And then once I figure this out, then I'll actually go to the full size, you know, fuselage or whatever I need to make that's big. Okay, back to the clay. This was, if you just tuned in, this is Pelican clay. And there was a composite shop that was buying this clay. I forget it's Pelican. But they sell this stuff in bricks, and it's usually yellow. Easy Composites will sell it, and it's usually in a brick like this. This I got on Amazon. It took me about 4 or 5 days to get it. I think it came from overseas, but basically this is a kid's clay. Okay, it comes in all different colors. But by buying the kids' clay and also looking at the other clay that you buy at a composite shop or Easy Composite, it's the same stuff. All they've done is added colors, you know. So if you just need a small batch, I mean, just get the kids' kit or whatever. And then, of course, if you have kids, you know, that's even better. They can play with it. I've also used clay that was American Art clay. It's in Indianapolis. It's been around forever. Matter of fact, this is the original Gumby clay, the formula. The Pokey and Gumby, if you're old enough, the stop animation thing, you know. So this has got sulfur in it. So if I was going to make a, what do I want to call it, silicone mold, the silicone wouldn't cure next to the sulfur in this clay. But it works out good for the epoxy and the surface coat that I use. But today on this landing gear thing, it's just live not really keeping up. Yeah, one of the things I noticed, live's not keeping up. It reconnected somehow. So I hate to do it, but the next step might be a 5G a 5G connection here. So I just hope it all ends up in the right spot, you know, or eventually it'll even out for you guys. I'm still learning as I go. Once I figure it out a little bit, then they change something. Okay, but yeah. So hopefully that helps a little bit. You know, there's a story, a guy that worked in a industrial setting. He was talking about silicone, and they use silicone as a mold filler, and they were going to use it as a pressure intensifier. And they had this aluminum mold with socket head cap screws, and basically what had happened, the big chunk of aluminum, it was a full-size part for an airplane. The big chunk of aluminum actually blew the socket head cap screws out because the silicone expanded with such force. Now, one of the things you'll notice, even though this gear is laying flat here, I still need to jam a little bit of clay around the edge right here, because you can see there's like a small little gap, and you're only talking maybe 10 thousandths or something. But what I want to do is fill that little gap, and that way I don't get any surface coat going underneath the part. This up here was pretty tight because there's glue seeping out of there. But yeah, down at the plate there was a little bit of a gap. So don't be afraid to jam this stuff down in little corners. So I think I got as much clay on here as I need. I'll scrape some of this off. Like I said, this is Composites 101. Hopefully I'll get to the point today, if everything works out on this crazy stream. I'd like to get to the point where I get the surface coat on this part. And don't worry about getting perfection. Basically just get the rough shape in there to begin with, and then I go back and fine tune it. So I scrape it pretty aggressive to start out with. So I'm sort of working some clay underneath that little gap. Now, even though you've got a draft angle on the part, you can also add to it by this clay. You know, I've added to the draft angle right here a little bit that was already into the part. Maybe when it's all said and done, it looks more uniform. So you can see how quick it goes. I remember when I first started doing this, the first time I tried forming the draft angle, I was trying to form it by actually tilting the spatula or the blade And then it occurred to me, why would I worry about doing that when I can actually grind the draft angle into the tool? Yeah, you mentioned that expanding foam into the mold, two Brits doing it, and they ended up breaking their mold, completely cracked. There's a video out. I know this stuff that I'm trying to do has already been done, or already attempted, for that matter. But hopefully I'll present enough information. I'll narrow it down to get rid of all the mistakes. So if somebody's going to do it, it'll work. But this guy made a video and he was doing a wing, and I don't know if it's the one you're talking about, but this guy, the wing, it was a mold, and he put expanding foam, and it showed the video of the foam just mushrooming. Now it looked like a, I don't know, it's pretty catastrophic. It was way overfilled. So I think the takeaway is everything's got to be controlled. You got to have the right amount of foam, the right foam. The temperature, I know it's temperature critical. There's a range you got to work in. But you know, one of the things that amazed me, I go to the RC field and they got these foamies. And these little foamies, you look at them and it's high production. There's nothing to them. It's just, you know, it's 100% mold. And these molds have got to be, you know, super accurate. But they're making these airplanes as cheap as they can make a cooler. I remember going to the gas station, and if you didn't have a cooler, you could buy these throwaway coolers. And these coolers were, I mean, back in the day, you know, a couple bucks, $5 for a cooler. And basically, you'd go to the track with it. When you're done with it, you could just throw it away. Same with a fishing trip. So basically, you know, these little foamy airplanes, the manufacturing process was the same thing as a throwaway cooler. Now I do know the guy was talking about the styrofoam itself. The styrofoam was resistant to some chemicals, so it's not expanded bead polystyrene. It's got something else in it. Now, if you wipe this clay off, and when you scrape it, if you get a void underneath it, you might have to pack it a little bit deeper. So what I'm doing here is adding more clay, and sometimes when you scrape it, you'll push it underneath the your gear. I know this is probably a little redundant here, a little boring, but another thing you find out when you start doing this stuff, it's the same with drywall. The faster you move your knife, you're going to get a different finish. And usually there's an optimum speed that you move. The slower you move, usually the better finish you got, to a certain extent. I don't know if you guys can hear it, but in the background, I got some squirrels out there that are barking. You hear the squirrels throwing a fit. And that's my cat. My cat gets out there and starts walking around, and the squirrels don't like it. But that's a good thing. Keeps the squirrels from chewing up my stuff. Now let's just say you had a hickey in the clay and you didn't catch it. You know, when it came time to open your mold, you could always file and sand or do whatever you had to do. Another thing, when I get it to this stage, basically what I've got to do is I've got to hold it up and look at it. I've got to get some light underneath it. Bounce some light off of it so I can see. So the next step is, once you get this clay where you want it, the next step is to actually wax it again. I use the wax to actually clean the film of the clay off too. There'll be areas on this part where you can see the clay. And if you get the light just right, you can tell if there's little gaps, or you can tell if there's undercuts. And that's what you don't want. You don't want any undercuts. If you did get an undercut, it'll still come apart. And basically what you're going to have to do is take a file on the mold that you just made and clean it up a little bit. So you can always go back and clean it up after the fact before you pour the second mold. The other thing that I might mention, the test piece I did on that styrofoam expanding foam in the glass was 2 pounds per cubic foot. Now, I'm sure that if you don't have enough expansion, or I guess you could say vents, you're going to end up with a density higher than 2 pounds, probably 3, 4, or 5, who knows. I do know with the expanding rubber foam, some of these guys use, it's sold with smooth on. You can control the density of your part by how much you vent it. So some of this foam, let's just say like for rubber tires that are self-skinning, like a Dubro tire, you know, it's got the smooth outer surface. That smooth outer surface is created by the back pressure. The more back pressure you have, the better your surface on that rubber tire is going to be. So it's real critical to get it dialed in. And then you got to play with the density, because just because you start out with 2 pounds per cubic foot, that doesn't mean you end up with it. And there's another variable. The expanding foam I showed you on that sample is urethane. They make 2 types of expanding foam that I'm aware of. One of them is epoxy base and the other is urethane. And I have a feeling that the epoxy foam is probably a little bit more rigid. It may be more stable. It's out of Europe somewhere. Another thing I'm going to mention, it might be beneficial for some people that have done a lot of composite work. And I just found this out the other day. Easy Composites, if you get on YouTube, which you're on there now if you're watching this, but get on the search and look for Easy Composites, and they've got a lot of videos that are professionally done. And they cover a lot of different processes and a lot of materials. And it's out of the UK, but the problem has always been they rattle off these products they're using, but you can order them, but the shipping was prohibitive and it took forever to get the product. I just noticed the other day, I was on my phone, and they've got a distributor in the United States. So if you always wanted to get your hands on the products that they sell, which are really sort of unique for the modeler. Now, a professional composite shop, they already have access to all that stuff because they buy in quantities. But for modelers, it's always been a problem. So, and even a big shop, if they just need a small quantity of something, it'll probably be beneficial to them. But they got a USA warehouse. So look into that. Do a search on Easy Composites US distributor, and it's all set up with the currency, the shipping from the States. And I remember I was watching a video, one of the last ones, they were talking about the possibility of that happening. And I guess they made it happen. So that'd be worth supporting them, you know, to get the small quantities of stuff. We're sort of lucky in the Indy area because there's a lot of race shops, and I remember back in the day when we were making our own fuel. You know, we had the national drags and all these race teams out here. You could actually, you know, go to the track and get you some nitro and get you some good methanol. The oil was never a problem to get, but some of the ingredients. But that was the advantage of living in a town that a lot of race teams were there. You could pick up the components, and let's just say you didn't brew your own fuel, but if I was flying competitively, I'd like to have a little extra components with more oil and nitro, or some of the ingredients where I could adjust on the fly. You got to remember, all this trouble on this draft angle, it really doesn't make too much difference because this isn't going to be your part. So if it's a little wavy or something, you know, don't worry about it. It's get it as close as you can. You know, I just don't want any big undercuts or anything. That's about as good as I'm going to get it. So my next step is, and I'll be right back, I'm going to grab a can of wax. I got some wax laying around here. Let me get that real quick. I've had this wax forever. This was a sample that was given to me years ago. I don't even think they make it anymore. I think Lily Ram 306B is the closest I've come to this. And you can still get a 306B Lily Ram. It's a sealer wax. This is a mold release number 1. AdTech. So I either use this or the Lily Ram stuff. So I got a little hole here. And when I shake it, basically it just enough comes out on this lid where I just get a little bit on the tip of this paper towel. And of course this has got wax fingerprints in it and everything. So I'll just lightly go over this part and I'll clean off my fingerprints and the wax residue. I try to stay away for the most part from my draft angle. Now I will come around here where it lays flat and I'll clean that up. The other neat thing with this wax, since it's so thin, it actually sort of melts the clay a little bit. So if the clay is a little rough or whatever, this will sort of blend it in. It'll allow you to, really smooth it out. It takes the right touch. But once you get that touch, it goes pretty quick. Try not to distort the clay. And that's the thing with the clay. You want the clay easy to form and scrape, but you don't want it so soft that you just barely touch it and distort it. There's a happy medium. Now, fiberglass, G-L-A-S-T, they sell some Chavant clay, and they sell different densities of it. And it's pricey, and they've got some videos talking about the properties of each type. In Chavant, I think that type of clay they're selling was used in the automotive industry to make their models, clay models. Yeah, it'll be interesting to see if this stream is going to be any good. Now, even though I'm at the wax stage, I'm not afraid to go back with the scraper and scrape a little bit. The other thing that helps